Good morning. Today's lab will be a gravimetric determination of the identity of a group 1 metal carbonate. A gravimetric analysis, simply put, is an analysis whereby one isolates a compound of interest and analyzes it by weighing it or massing it. It is one of the simplest ways of analyzing materials. Most compounds come in reagent bottles that are clearly labeled with the contents inside, their formulas, the amounts, masses or volumes, and concentrations if they're solutions. Occasionally, we come across bottles that have torn or missing labels, and we do not know the important details about what's inside those bottles. Today's lab is meant to simulate this scenario. First, you should know that all group 1 carbonates are soluble in water. This means that when they're placed in water, they dissociate into ions and are hydrated by water molecules as shown. Such solutions contain ions of the salts that were dissolved. Just for reference, you should know that all compounds that contain group 1 ions, ammonium or nitrate, are all soluble in water. Carbonates are generally insoluble unless, of course, they contain a group 1 ion or ammonium. Calcium carbonate is one such carbonate that is insoluble in water. This means that it remains undissolved and eventually settles to the bottom of the beaker if we try to mix it or dissolve it. We will utilize this fact in our lab. How so? Well, the first thing we're going to do is we're going to dissolve the group 1 carbonate in water. We'll have a second solution of calcium chloride, an aqueous solution that will be added to stoichiometric excess to the group 1 carbonate. So essentially we'll mix the two solutions together. And what will happen is calcium carbonate will be formed, and you might recognize this reaction as a double replacement reaction. And since calcium carbonate is insoluble in water, it will precipitate to the bottom of the beaker. After it precipitates, we'll wash the precipitate with distilled water, we'll dry it overnight, and then mass it. So the strategy moving forward is to measure the group 1 carbonate. We'll measure it so we have a known mass of the group 1 carbonate. Then we'll dissolve the group 1 carbonate in water. We'll add an excess of aqueous calcium chloride to form the precipitate calcium carbonate. We'll dry and mass the calcium carbonate, and then we'll determine the molar mass of the unknown carbonate using the stoichiometric relationships. And from here, we can determine the identity of the group 1 carbonate. So how would this play out? So I have some sample data here, whereby we have a mass, an initial mass of 5 grams, 5.001 grams of the unknown carbonate. Suppose after going through the process, we obtain a dry mass of calcium carbonate of 4.722 grams. From here, we can determine the number of moles of the unknown carbonate that should have reacted, again using the stoichiometric relationships. Because we've massed the unknown carbonate using the number of moles and the mass of the carbonate, we can determine the molar mass of the unknown carbonate by dividing the mass of the carbonate divided by the number of moles of the carbonate. And from here, we get 105.98 grams per mole. Using molar masses of known carbonates, we can simply match up the molar mass that we determined from experiment with the molar mass of known carbonates, and from here we can determine the identity of the unknown metal carbonate.
Okay, so I just want to introduce you to a little bit of glassware. This first device is something called a Gooch crucible, and basically we'll be using this to filter the materials. If you look very closely, you'll see that there are holes through which liquids may be, pull through the filter glass. We use a piece of filter paper with this, which I'll show you in a few minutes. This is something called a Walter adapter. And the way this works is the Gooch crucible fits inside of the Walter adapter, so that when filtration is occurring, the Gooch crucible has a place to sit. We'll be using standard beakers. We'll use 2 sizes, and then we'll use something called a filter flask. Let me show you this real quick. So this is a filter flask, and the way it works is the Walter adapter, I showed you before, Walter adapter sits inside of the filter flask, and the Gooch crucible sits on top of that. This little arm sticking out of the side goes to something called an aspirator. And the way this works is the aspirator is a device that when you connect it to the sink, it creates a vacuum. And the way it works is, I can try to turn this camera so you can see how it all fits together. The aspirator fits into the filter flask like so. And when I connect the aspirator to the sink, it creates a vacuum that pulls the liquid through the Gooch crucible that allows the material to be filtered through, again, vacuum filtration. Okay, so this is the unknown metal carbonate, group 1 carbonate. Note that it is a white solid. I'm going to measure the mass of the group 1 carbonate by heading over to my analytical scale. I'm going to start with a clean weigh boat and place it on the stage. Note that as I put the weigh boat on the scale, notice that it registers the mass, which is about 2.39 grams, but I'm going to zero this out just so I can get the mass of just the group 1 carbonate. So let me try to get as close to 2 grams. That's what I'm trying to achieve here, 2 grams. I'm not going to try to get exactly 2 grams. What's important here is that I can measure the mass, or know the mass accurately of the group 1 carbonate. So getting close. Okay, so I'm a little bit over. That's okay. Let me just close the door so you can see that. So notice that that is about 2.1009 grams. Okay, so that will be the mass of the group 1 carbonate, which you should note in your data table. The next thing we're going to do is measure the mass of the Gooch crucible and the filter paper. The filter paper I mentioned before, you can see that is very small, fits inside the Gooch crucible. I'm going to place that inside, and I'm going to measure the mass of the filter paper and the Gooch crucible together. You'll see why this is necessary as the lab proceeds. Let me zero out my scale again, place that on top. Okay, so note the mass of the crucible and the filter paper is 21.5768 grams. Okay, so the next step is to dissolve the group 1 carbonate in a suitable amount of water. So I'm going to place the measured mass of the group 1 carbonate into a beaker. And I'm going to be careful to make sure I get all of it. You see there's still some residual there. I'm going to use a wash bottle to wash the remaining amount of my carbonate into the beaker. Okay, so I've done a reasonably good job of washing all of the remaining carbonate into the beaker. And then I'm going to, not trying to be careful to measure the amount of water that I'm adding here, but I do want to make sure that the
carbonate does dissolve. By the way, I'm using distilled water for this exercise. We always use distilled water because the water is relatively free of impurities and things that might cause precipitation reactions. So I'm going to give that a good swirl. These group 1 carbonates are fairly soluble in water, so that should dissolve fairly quickly. Almost done. Let me add a little more water. Looks like I almost there. Still some minor turbidity in the solution. Add a little more water, make sure. Again, not important to measure the amount of water that I'm adding here. What I'm really trying to achieve is to make sure I've completely dissolved the group 1 carbonate. Okay, that looks pretty good. Okay, the next step is to add about 125 milliliters of 0.2 molar calcium chloride to my solution of the group 1 metal carbonate. I've changed my perspective here simply to show you what the precipitation reaction looks like. So I'm going to slowly pour this. Hopefully I get the Okay, so notice that the solution becomes very cloudy. Let me kind of look at the top. Sort of looks very milky. That white color that you're seeing is the precipitation of the calcium carbonate. Over time, the calcium carbonate will settle out and move to the bottom. Okay, the next step of the lab is to vacuum filter the precipitated calcium carbonate that's in our beaker here. So I'm going to turn on the filtration apparatus. Remember the aspirator that was connected to the sink? Again, this creates a vacuum, which again, when I pour the calcium carbonate mixture through the gooch filter, the vacuum will pull out the liquid, and what should remain inside of the gooch crucible is my calcium carbonate solid. I'm going to turn the water on, and before I start, I want to get this filter wet a little bit so it forms a seal, so the calcium carbonate shouldn't be pulled through. I'm just going to wet the filter paper a little bit. Notice how the liquid is being pulled through the gooch crucible. That is the effect of the vacuum, or the vacuum that's created by the aspirator. Okay, so the process is more or less complete. You might see that I have some solid that is wet inside of the gooch crucible. The liquid underneath is relatively clear. It wasn't initially. I noticed some turbidity in the mixture at the bottom, which suggested to me that some of the calcium carbonate was being pulled through. But then I filtered it again, and filtered the mixture at the bottom, and was able to recover any lost calcium carbonate. The next step would be to take the gooch crucible with my filter paper and my calcium carbonate and dry it. To dry the calcium carbonate, what I'm going to do is place it on a watch glass. This is the drying oven we have in the back of the room. I'm going to open that up and place my calcium carbonate inside. We'll set that for about 100 degrees, maybe less, 80 degrees Celsius, and we'll heat that overnight. Okay, so at this point we're going to measure the mass of the dried calcium carbonate that I removed from the oven. So place it on my scale. And the current reading is 23.0735 grams. Again, this is the mass of the Gooch crucible, filter paper, and the calcium carbonate.